Alright, ladies and gentlemen. Right on top of your thing here, similar polygons. In order for things to be similar, remember what they were? We talked about similarity at some point in our lifetime. Similar shapes are, John?
Of same shape.
And same shape in the sense that they must also be what we call proportional. And that's what we shall talk about just a little bit here. So let us say I have one triangle. Well, let's do this triangle here. Okay, so here's a triangle. Okay, in order for something to be similar to it, the basic gist is this. You know, this triangle is not similar. Okay, because it's a much thinner, taller triangle than this. If I'm going to make it similar, well, here, let's do this. It has to be like a balloon. Would you call that kind of similar? Are we close? Somebody say yes. In order for two triangles to be similar, they have to be proportional. In other words, if this was a balloon and I blew it up, it would end up, the sides would increase by the same amount at the same rate. And that is where the proportional part comes from. But before we talk about that, let's say I've got my triangle A and my triangle B. There are a couple things that are true with similar shapes. If, well, let me label this too. What shall we call this? Let's go A, B, C, D, E, and F. Write this down because this is a little geometry for you. If two shapes are similar, comma, their corresponding angles are equal. Now you won't know what that means until we discuss this just a little bit, but write it down because it'll be something of value later on in the proverbial lives. Got that? Before we go any farther, Braid and Twig, we must figure out what that long word corresponding means. Do anybody out there in the 7th grade class know what corresponding might mean, or have a speculation of corresponding? John Deffenberg, do you have a speculation? Are you getting a revelation? Are you feeling something?
Kind of like, I don't know. It's like similar kind of. I can't.
What does corresponding mean? Corresponding means basically the things that match up. Angles or sides that match up. Angles, and I'm going to put match up in parentheses. And by that, for this thing here, if you're looking at the angles that match up, the small angle on this one corresponds, angle B would correspond to angle E. They're the ones that match up. If you were taking this shape, putting it over top of this shape, and then actually blowing it up like a balloon, those would be the angles that would match up. Angle E would match up with angle B, angle D with angle A, and angle F with angle C. Now what that means is this, ladies and gentlemen. If you have two shapes that are similar, their corresponding angles are equal. That means this. If this angle is 35 degrees, then so is this angle. They are both 35 degrees. No matter how small I make that triangle, I'm still going to have a 35-degree angle if it is similar to this. Same thing, let's say these sides are probably the same. So, oh gosh, if they're the same, what would they be? Let's pretend they're not. If this angle was 70 degrees, then this angle would have to be 70 degrees. And if that were the case, what's my third angle? I don't know what the third angle would have to be. Triangles add up to 180 degrees, 70 plus 35 plus what? Everybody do that? 105, one number add 105? Jonah? Thank you, 75 degrees. This was taking too long. 75 degrees. So corresponding angles are equal. And then we have one more big revelation that says corresponding sides are, anybody? Not equal, don't say equal, John?
Sides that match up.
Yeah, well they are the sides that match up, but I want to know what they are. Like these said corresponding angles were equal. Corresponding sides are, I'll just give it to you, they're proportional. But you said that before, but we need to talk about what that means. That means, just like with the little ratio boxes that we made, you can make ratio boxes if you know two shapes are similar, you can make a ratio box with them. For example, let's say this side on the small one was 4, and this side on the big one is 8. If I know that this side is 7, I can use that ratio, that proportion, to find out what this side is. How would I do that, you ask, Anna Baumgartner? Well, one way is we can make a ratio table, which is always good to do. Okay, in the ratio table, you would have one triangle, triangle A, compared to triangle B. Because they form equal ratios, they're proportional. And then the sides would be, what am I comparing? Well, here, this 4 is the short side, so let's compare their short sides to the left side. What is the short side on triangle A? 8, correct? What is the short side on triangle B? Jump in here anytime, kids. 4. What is the long side on triangle A? I don't know. What is the long side on triangle B? 7. And that is our ratio box, which you can solve just by making them, pretending these are equal fractions. 4 7s equals 8 over what number? To go from 4 to 8, you do what? Multiply by 2, so to go from 7 to there, you multiply by 2, which is
14.
14. Got that? And along those same lines, ladies and gentlemen, this thing that we multiply by, this times 2, is what we call the scale factor. It is what we call the scale factor. And really, you don't almost have to do this, because if you know that this side was 6, you just multiply 6 by the scale factor, and it's going to tell you this side over here. This triangle is twice, the dimensions are twice the size of that triangle, because its scale factor is 2. Now, we could do that also with a, well, let's see if we can draw another shape. Do we not get just regular old, wait, what does this button do? Shape recognition. Oh, it did do something. Holy dooties. That is sweet. Can I change this? So, here's the deal. Let's say I've got this one, and I copy and I paste it. Wait, do you think that shape recognition? If I did an octagon, would that recognize it? Wait, let's try. 1, 2, 3. Oh, that's a hexagon. 4. So, if you've got this one, let's make it proportional. Does that look proportional yet? No. What do I have to do? Tell me when you think it looks like it's.
Yeah, right there.
You really think those are? Based on what we know, and the book will tell you if you have similar shapes, so let's say these are similar. Okay. If this one was 3 inches and this one is 9 inches, right off the bat you can tell me the scale factor between the two, because it is simply what do I multiply this 3 by to get 9, which is 3. Thank you, whoever was thinking of it didn't want to say it. Which would mean if this side was 2, how long would this side be? 6. And again, if this side is 1, if this angle is 100 degrees, guess what this angle is? Not 200. Scale factor doesn't work with angles. Angles of similar shapes are the same. That's also 100 degrees. If this is 80 degrees, this is 80 degrees. This would also be 100 degrees, 100 degrees, 80 degrees, 80 degrees. Let's see if I missed something there. And then a blanco piece of paper, please. Because we have one more piece of I'll make sure you know this, the word congruent shapes. What does congruent shapes mean? How is that different than similar? Congruent means they are exactly the same. Both size and shape. I want to play with this again. I'm going to draw a 10-sided shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, boo. 1, 2, no. Oh, it did that. It did straighten stuff out. Wait.
What? It makes a pee-pee.
Square. Not bad. A square. I guess it has its uses there. Congruent just means it's exactly the same, so it isn't going to change. I mean, nothing's going to change. That's enough of that, just so you have it there. Now, look in your books.